This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on the definition of the derivative. So we're going to start with the slope of a secant. So what exactly is a secant? We have a function here in blue. We have a point here, x, f of x, and we're going to move off of x a little bit. We're going to add h. And our second point is at x plus h, comma, f of x plus h. And we want to find the slope of that secant. So what is the slope of that line going to be? What do we recall? Slope is y2 minus y1 over x2 minus x1. In calculus, we prefer to say that slope is change in y over change in x, just to get us ready. And that, of course, will become dy dx as change in x goes to 0. So change in y, f of x plus h minus f of x. Change in x, x plus h minus x. That would be the slope of that secant. X plus h minus x would just leave h downstairs. And the slope of our secant is f of x plus h minus f of x over h. This is the foundation for the definition of the derivative. What we're going to do is we're going to shrink h. We're going to move h closer and closer to 0, so x plus h gets closer and closer to x. How is that going to change things? So let's look at this set of secants. So with this function in red, our first secant goes from p to q for that value of h. And you'll notice what's happening here is as we go from this point to this point to this point to this point, h gets smaller and smaller each time. And what's happening is the secant is becoming closer and closer to the tangent. So if h is very, very, very small, you'll see that the slope of the secant is very close to the slope of the tangent. So we're going to shrink h to 0 for our slope of the secant. So to get the slope of the tangent, we start with the slope of the secant, f of x plus h minus f of x over h. But to get the slope of the tangent, we're going to take the limit as h goes to 0, shrink that. So this might be the next secant, this might be the next secant. As h gets smaller and smaller, eventually that will start to look like the slope of the tangent. So the slope of the tangent is the limit as h goes to 0 of f of x plus h minus f of x over h. And that is our derivative function. That gives us the slope of the tangent at any point x. The slope of the tangent is the limit as h goes to 0 of f of x plus h minus f of x over h. That is our definition of a derivative. And we say that f prime of x equals that, and it represents the slope of the tangent. Now f prime of 2, if we would plug 2 into that function, that would be the limit as h goes to 0, f of 2 plus h minus f of 2 over h. That gives us the slope of the tangent 2. F prime of x gives us the slope of the tangent everywhere. So this is typically what we're going to find. We're going to find f prime of x, find the slope of the tangent for every point x. That'll be our derivative function, f prime of x. So here's our first example. F of x equals 2x squared minus 5x plus 3. We want to use the definition of the derivative to find f prime of x. Remember, f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. So to do that, I'm first going to find what f of x plus h is. Because in that formula, that's going to be the hardest thing for us to work with. In our formula here, f of x plus h is what we have to find. So I'm going to find f of x plus h here. So it's going to be plugging in x plus h for every x. 2 times quantity x plus h squared minus 5 times x plus h plus 3. And now it comes time for some algebra. So what is x plus h squared? That's x plus h times x plus h. We start with x times x, that's x squared. Next up, h times x is hx. X times h, also hx. H times h, h squared. Adding all this together, x squared plus hx plus hx plus h squared, x squared plus 2hx plus h squared will be our x plus h squared. So let's make that substitution. So for x plus h squared, we have x squared plus 2hx plus h squared. And then distribute 2x squared plus 4xh plus 2h squared there. Distribute the negative 5x minus 5h. So be very careful with distributing negative signs. That's a common mistake to make. So again, negative 5x here, negative 5h there. This is f of x plus h. Our rule requires the limit as h goes to 0 f of x plus h minus f of x all divided by h. So where do we go next? There was the f of x plus h we just had on the previous slide. And here's f of x, which we have up here, 2x squared minus 5x plus 3. If we subtract these, if we take f of x plus h minus f of x, the x squareds go away. Negative 5x minus negative 5x is 0. 3 minus 3 is 0. So if we subtract, all we're left with is 4xh plus 2h squared minus 5h. And our rule requires us to do f of x plus h minus f of x over h. You'll notice here we have an h in every one of these terms. I can factor that thing out as well. So factoring out that h, you can see when I divide this by h, that h will cancel. So my algebraic work right now, f of x plus h minus f of x is h times 4x plus 2h minus 5. But our rule is we need f of x plus h minus f of x over h, and you'll see those h's will cancel. But the derivative is the limit as h goes to 0 of all this. So I'll finish it by saying limit as h goes to 0 of both sides here will be our derivative function. F prime of x, limit as h goes to 0, f of x plus h minus f of x over h. So that's the limit as h goes to 0 of 4x plus 2h minus 5. Plug a 0 in for h. 4x plus 2 times 0 minus 5, and our derivative function is 4x minus 5. And let's take a look at another example. Same idea. We have f of x is 3x squared plus 7x minus 9. We want to use the definition of the derivative to find f prime of x. F of x plus h, plug x plus h in for every x. 3 times x plus h squared plus 7 times x plus h minus 9. I've got to do x plus h squared again, but I did that in the previous section, remember. X plus h squared was x squared plus 2xh plus h squared. Distributing this, 3x squared plus 6xh plus 3h squared. Distributing this, plus 7x plus 7h minus 9. And our rule is f of x plus h minus f of x over h. We have f of x plus h. Next, subtract f of x. F of x plus h on top, subtract f of x. 3x squared minus 3x squared gone. 7x minus 7x gone. Negative 9 minus negative 9. Negative 9 plus 9 is 0. What will be left is 6xh plus 3h squared plus 7h for f of x plus h minus f of x. Factoring the h out of this, that will leave me h times 6x plus 3h plus 7, factoring out the h. H times 6x plus 3h plus 7. And you know we need f of x plus h minus f of x over h. Doing that, the h's cancel. And f of x plus h minus f of x over h just becomes 6x plus 3h plus 7. The derivative requires me to take the limit as h goes to 0 of this. So all we're going to do is plug in a 0 for h. F prime of x is the limit as h goes to 0 of that. So plug in a 0 for h. And we get 6x plus 3 times 0 plus 7, or our derivative function will be 6x plus 7. Okay, we got one more example to look at here with the square root function. F of x is the square root of x plus 5. We want to find f prime of x. So we need f of x plus h minus f of x over h, then take the limit as h goes to 0. So the first step is f of x plus h. Replace x with x plus h. So f of x plus h is the square root of x plus h plus 5. F of x is that, so if I subtract them, f of x plus h minus f of x, it will be the square root of x plus h plus 5 minus the square root of x plus 5. And I want to divide that whole thing by h to get it in the form I need, f of x plus h minus f of x over h. So that's what I need. And to do this, if I plug in 0 here, I get root x plus 5 minus root x plus 5, 0 on top. Plug in 0 downstairs, I get a 0 over 0 case. So I need to rationalize the numerator if I'm going to simplify this. Now that gets tricky. You have to multiply top and bottom by the conjugate. So it would be root x plus h plus 5 plus root x plus 5 over the same thing, root x plus h plus 5 plus root x plus 5. So let me show you that. Here's our fraction from up here multiplying the same thing on the top and the bottom, which is the conjugate of the top. Again, root x plus h plus 5 minus root x plus 5, his conjugate, root x plus h plus 5 plus root x plus 5. Whatever you multiply on the top, you've got to multiply on the bottom. So now I've got to multiply this piece by this piece. On the bottom, we're just going to take h times the parentheses, but the numerator multiplication is the challenging part here. So how do we do that? How do we do this piece times this piece? First times first, first times last, inners, outers. You can think of it that way. I like to visualize it. So I have root x plus h plus 5 minus root x plus 5 here, root x plus h plus 5 plus root x plus 5 there. This times this, x plus h plus 5. Square root of 2 times square root of 2 is 2. Square root of something times square root of something is the something. Next up, negative root x plus 5 times positive root x plus 5 would just be the negative of x plus 5. These two guys are a little tricky. Root x plus 5 times root x plus h plus 5 here. That's the length, that's the width, that goes in that cell. Down here, negative root x plus 5 times root x plus h plus 5. And these two things will cancel. You'll notice they are opposite of each other. So adding all these together, I have x plus h plus 5 minus x plus 5. Distributing the minus sign, minus x minus 5. And all that's left is h. So for all of that work, the only thing that's left in the numerator is h. And remember, this was f of x plus h minus f of x over h. So on top, all that's left is h. On the bottom, I have h times square root of x plus h plus 5 plus root x plus 5. And you'll notice the h's cancel. Those go away. H over h just gives me 1 over root x plus h plus 5 plus root x plus 5. But to get the derivative, I've got to take the limit as h goes to 0. So plugging in a 0 here, you can see where that's going to go. F prime of x, limit as h goes to 0 of that. That was on our previous page. 1 over root x plus h plus 5 plus root x plus 5. Plug in the 0 for h. 1 over root x plus 0 plus 5 plus root x plus 5, which gives me 1 over root x plus 5 plus root x plus 5, or 1 over 2 times the square root of x plus 5. And that will conclude this lesson.